Welcome to this module of Professor Messer's free CompTIA Network Plus certification training course, the online training course that likes rainy days and long walks on the beach. I'm James Messer, and in this module, we're going to talk about user authentication. That's an important part about getting onto networks and authenticating people and making sure that we let the good people in and the bad people out. There's a lot of different ways to authenticate, and this comes from our N10-004, section 6.4, where we need to understand PKI, Kerberos, AAA, which exists in the radius and TACAX areas, the network access control, 802.1x specifically, and then CHAP, ms-chap, and EAP or EAP. Now we're going to go through each one of those. I've changed around the format of this just a little bit. So what we'll do is start from a user authentication piece and work our way into how those things are being used on your network. User authentication itself is a pretty important security environment. You can think about how many times a day you authenticate where you're typing in a username and password. And then there's also times when you're not typing in a username and password where you are also being authenticated. So all of those things all work together. And unless the authentication is in place to allow you access, you're not going to be able to get into the network. There are many, many different ways to authenticate in. We're just going to talk about a few of them today, but there's combinations of usernames and passwords. You may have been given a token generator. I have one for PayPal. I must put in my PayPal username, my PayPal password, and then it asks me to type in the number that's on my token generator. I have to find my token generator and hit the button, and I always keep it nearby. It's right here. So I hit the token generator button, and it tells me what the number is on there, and that number changes every 30 seconds or so. And then it knows that it's me because I'm the only one who has that number that's on that keychain. If I lose that, I don't have access to PayPal anymore. There's also fingerprint readers. That's another way to authenticate, which is biometrics. It looks at your human beingness and tries to figure out if you're really you based on what your fingerprint looks like. You can't get much more secure than that. As we go through this module, one thing you'll find is that secure authentication has a lot of cryptography associated with it. There are a lot of mathematics that go on back and forth dealing with cryptography and the way that it operates. We're not going to dive into how it's doing all of that behind the scenes. We're going to go into a little bit of what we see from the outside. But if you really are interested in cryptography and you're interested in how it's working, there is an entire science behind the scenes of how all of this works. You could certainly make a career doing nothing but understanding the mechanics of cryptography and the way that we use this on the network. Before we start talking too much about the details of how the cryptography and the user authentication works, one concept I wanted to bring up is this first foray into cryptography called a hash function. This is a cryptographic function that behind the scenes, again, is very complex in the way that it works. But what it essentially is doing is providing a one-way function so that I can take a piece of information and provide a standard type of hash of that configuration, and I can't reverse that. You can't. It's a one way to go that way. I can't take the hash and somehow figure out what originally generated the hash. That's one of the great parts about this, and one of the interesting parts cryptographically about how this works. We call that hash a digest. So we can take a very long bit of text. We could take pages and pages of text. We can take entire files, multi-gigabyte files, and create a hash of that. And we know on the other end, if we download that file and we try to perform the same cryptographic hashing function, those two hashes should be identical. We can also do some interesting things with these algorithms. There's two primary digest algorithms that we're going to talk about today and that you'll probably see out there. One's called MD5, which stands for Message Digest Algorithm 5, and SHA, or SHA, Secure Hash Algorithms. This hashing function means that I could take something like a password. You're starting to see how this works in our security piece. Take that whole password, for instance, the word password 111, and change it so it looks like this if I hash it with an MD5 algorithm. Now that looks nothing like password 1, and more interestingly, I can't take this hash and somehow work backwards to come up with password 111. It's impossible to do, which makes this very useful. Here's how. Let's say that I'm trying to authenticate on the network. I'm out here on my client, and there's a server, and I asked the server, please allow me access to a resource on the server. And the server is going to say, Well, before you do that, you need to authenticate. You need to give me your username and password. So I'm going to type in my username. I'm going to type in password 111. It comes up, of course, as asterisks here, but we don't send password 111 across the network. If somebody was sitting there with an analyzer, they were capturing the packets, they could very easily see my password. So what my machine does is this little box, before it sends it, does an MD5 hash of password 111 and sends back the hash. Now that means that on the other side, originally, when I set up this password, it was also hashed, and the hash is stored somewhere on the server. What the server does is look at this hash I just sent, it compares it to the hash that's already in the database, and then it sees, did you use the right password? It doesn't know what I typed in, it just knows what the hash was that it received. And that's pretty ingenious, because now I can set up a different password, put a different hash on the server, and I'm not sending my real password down the line. If you're ever talking with somebody on the phone who says you need to change your password, well, you can ask them, well, what was my password? I don't know. And they don't know because all they really have is this hash on the other end to look at. They didn't keep, they don't know, they have no idea what your password originally was. It's this hashing process that is the fundamental piece of CHAP and ms-chap. Now, these are authentication message protocols where you can challenge and handshake. And this is the process that we were just looking at, where there is a challenge where you need to give me a username and password. There is a response in the form of a hash, and then there's a check for the match. So the CHAP, the challenge handshake authentication protocol, was one that was original. And then Microsoft added on a couple of extra functions so that you could change the password using it. It added some extra security functionality to it that was very specific to Microsoft. So as you're setting up remote access or remote authentication methods, and it's saying, are you going to use CHAP? Or are you going to use ms-chap? This is what it's referring to as those two methodologies to be able to do it. Our most modern authentication methods don't use CHAP and ms-chap much any longer, primarily because there is a way that someone could sit in the middle of that conversation and send back the different hashes and be a man in the middle and somehow get access to what you're doing. We needed something that was much stronger in the way that it operated, and so the industry came up with Extensible Authentication Protocol, or EAP. This is a framework, really, for authentication. It's a standardized way to authenticate, and it is one common methodology, and you just get to decide within that methodology how you're going to authenticate. It is extremely flexible, and you'll start to see EAP pop up in many places. We've already talked about it a little bit in a previous module because there's many methods built into this. I can do ms-chap inside of EAP. I can do MD5. I can do TLS. I can do LEAP and PEEP. Look at all these different methods, and I didn't write out all of them. I think there's about 40 different methods inside of EAP that I could be using. But these are some very common ones, and these are the names that you will see pop up a lot when you're configuring an EAP authentication method. You'll also see this in many different networking environments, whether it's a wireless network, especially in a wireless network, because that could just go everywhere. But you also see it in local area networks. You see it a lot in wide area networks and point-to-point networks. It's a very extensible authentication protocol and therefore can be used on many different kinds of networks. Although the hash is an important part of the authentication process, it's also something that you shouldn't take lightly. The idea is that if somebody had the hash, they could possibly find a way to compromise your system if they had enough time and enough resources. So the hash by itself is something that you should probably keep very private, because let's say that you just ran through every possible password, compared the hash of what you were typing in with the hash of what you think somebody else is using across the network that we captured, and I'm just looking for a match. We often see this with dictionary attacks because people will use common words as their password. We'll see it with brute force attacks. Just go through every possible combination of every possible letter and every possible number until I come up with a match. Very easy to do that. There's some very simplified ways to do that these days as well. Now, you may think, gosh, that might take a while if you did that. But in cryptography, there's a very interesting problem called the birthday problem. And the birthday problem says that if you got a bunch of people together in a room, get at least 23 people chosen at random, stick them in a room. And then you ask each one of them, what is your birthday? The probability is more than 50% that a pair of those people will have the same birthday. I know, I don't get it either. And yet that is realistically in cryptography and mathematically speaking, that's absolutely valid. Don't trust me? Wikipedia this. You'll spend hours trying to figure that out in your mind. But that tends to be a bit of an issue now. We don't even have to go through every single possible function to ultimately figure out what the match is going to be. So don't think that somebody can't get a hash and backwards or brute force engineer this. They'll find a way to figure out a matching hash. And when they do that, they've got your password. Well, how do I get around that then? I've got this hash and I need to protect it. I don't want to send my hash in the clear across the network now, because if somebody gets their hands on that, they may be able to figure out my password. Well, fortunately, those smart cryptographers have come out with other ways to protect our data, and one common way is something called public key cryptography. The idea is that I can build a pair of keys that are cryptographically linked. We build them together, and then we can break them apart, and I have a public key and I have a private key. The public key is the one that I can give to the public. I can give it to anybody and say, if you're going to send me something, encrypt it with this public key that I've built, and I will be able to read it. And I can give that public key to anybody. And as long as they use a standardized method with that key and send it to me, we're still safe. Nobody can really get into that data. I decrypt the data with the other part of that key that I keep private to me. That is my private key. And when I say private, I mean very private. If somebody gets a hold of that private key, you now might have a problem with somebody being able to read your encrypted data. The public key, give it to the world. Post it publicly on a website. That's where you see these posted generally. And keep your private key somewhere that only you would have access to it. This is something called an asymmetric key algorithm, which means that the key that you're decrypting with is different than the key that you encrypted with. And that's something we're not accustomed to generally. If you've never seen this before, you would think that somebody would use a password on their side and you use the same password on your side. A lot like the guy who has to carry the briefcase and everything is padlocked to him, and that briefcase has to come all the way through and it has to be private the whole way. Not so much with asymmetric key algorithms. I can give my public key to the world, and all I have to do is keep my very tightly handcuffed private key close to me. If you're in an environment that's very large, even medium-sized businesses these days, you may think of putting together something that's called a public key infrastructure. This becomes very important if you're doing a lot of encryption, and it's a very important part of what you do as a business. So you'll hear this referred to as PKI. It is a formalized set of policies and procedures surrounding that asymmetric key methodology that we were just talking about. Imagine if you had all these public keys and private keys for everybody in your organization, and then somebody lost their private key. But you still had very important data that belonged to the company that's on the hard drive, and now you wouldn't be able to encrypt it. That wouldn't make much sense. So there's methodologies and policies and procedures that would allow the company to also have a private key that would allow them to decrypt these pieces. The PKI is just a way to create, to manage, to store, to distribute, to revoke keys. This is not a very simple thing. This is a complex set of policies. There's got to be some technology behind this to be able to manage these processes. You have to be able to handle browser incompatibilities. What if an employee comes on board? How do they get their keys? What if an employee leaves? What do you do with their keys? There's a lot of questions that have to be answered. At the end of the day, all of these keys with their private key and their public key and all those other pieces ultimately are based on trust. You have to be sure, you have to trust that somebody giving you the public key, that it's not being compromised somewhere down the line. And you have to trust that if you're encrypting it and sending it in, that you're using a set of keys that is indeed private. Nobody else would have access to it. At the end of the day, it all comes back to human beings. And that's one of the things, whenever you see somebody that has compromised some type of encryption methodology that uses PKI, sometimes what they're doing is getting around the processes and getting a certificate they shouldn't have, because ultimately it's human beings that have to handle these things. A very common way of authenticating that takes advantage of some of these latest technologies and private keys and this asymmetric key algorithms, and also integrates some of those other methodologies we've been talking about, is called Kerberos. This is an open network authentication protocol. Because it's open, many different operating systems can use it. It's used by Microsoft Windows. It's used by Mac OS, Solaris, FreeBSD, Linux uses it. It's a very common way to authenticate people to provide them access to resources. This takes advantage of that asymmetric key methodology using public key cryptography. So already we're kind of getting past the idea of sending hashes in the clear, and instead we are encrypting data using these methodologies that we know are tried and true and that work very nicely. Whenever we talk about Kerberos, you're going to hear people talk about getting tickets. And that is an authentication server that's granting authentication to the network, and a ticket granting server that's giving you a ticket that will allow you to access what you are deserving to access. Only the things that you have rights and permissions to be able to have access to. Now, Kerberos, because it has these multiple servers, it uses this public key cryptography. It has quite a bit of infrastructure you already have to have in place to be able to run it. It really is designed for the enterprise. There are centralized servers that run this Kerberos process, and there is this centralized server has all of those secret keys on it. If you lose that centralized server, there better be a backup server somewhere, or else nobody on the network would be able to authenticate. So you can see it really is something that you would use in very large environments that have the infrastructure to be able to support something like this. Another way of authenticating people is to use something called AAA. AAA. This is not the American Automobile Association. This stands for Authentication, Authorization, and Accounting. What we're doing is making sure in a centralized server that we can identify who someone might be, provide them access to what they need to have access to, and then ultimately make sure you know what they're doing. Track them, log them, know that they logged in, know that they logged out, and keep track of perhaps what they did in the meantime. AAA is very common to find in medium to large environments. If you're dialing into a network or you need authentication on the network from somewhere else, you will need AAA. And because of that, you'll even sometimes see it in smaller environments too. Just depends on how much authentication you really need to be able to get into the network. If you want to use AAA, we usually do this through a couple of different well-known methodologies. One is called Radius. Radius stands for Remote Authentication Dial-In User Service. It uses a AAA methodology so that it can be supported across many operating systems, many applications. If you are logging into the network remotely, you may be putting in a username and password, and it may be using the Radius protocols to be able to allow you access into the network. If you're logging into your switch to be able to configure it, it may be using Radius to authenticate you. So those are completely different things. Logging into a firewall, logging into a switch, logging into a remote access device, and yet it's a very common way using these Radius protocols to be able to authenticate you in the network. It makes it easy. If something is not integrated into the methodology you have already, that Radius can give you that little hook that allows you to authenticate people in using exactly the same credentials that they always use on your network. Another common AAA methodology is called TACACS+. That stands for Terminal Access Controller Access Control System. It was created by Cisco primarily to provide access to their infrastructure devices, to provide access to routers, to provide access to switches. Because it's Cisco-centric, you usually only see this in places that have Cisco and Cisco only. You really do find Radius a little bit more. The challenge, though, is that TACACS+ is a little bit more streamlined and has a little bit more functionality than Radius. So it's almost a combination. You have to balance the two out. Which one would I like to use? Would I like to use Radius, or would I like to use TACACS+? And in some environments, you can actually have both all working simultaneously. Let's say you've got a Radius server now running, you've got a TACACS server now running. You'd like to use it to authenticate people to the network, and one very common way to do that is to tell your access point only allow people on this wireless network if they have authenticated to our Radius server or authenticated to our TACACS+ server. And it does that using a common network access control called IEEE 802.1x. This is a common authentication method that gives you access to the network. So this is a network authentication method. I'm not getting access to files. I'm not getting access to a printer. I'm just getting access to the network. This is my first step before I can even do anything else. You see this a lot in wireless networks because there's no reins on a wireless network. You can be in the parking lot and be on a wireless network. So you want to be sure you have some way to authenticate people before they even get into the network. This uses, by the way, EAP. The Extensible Authentication Protocol. Another good example of how EAP can be used to authenticate people onto the network, and just one of the many ways that it can be used. It usually authenticates against a Radius server. It can authenticate against a TACACS+ server with some access points. Ideally, the Radius server then has access into the central database so that you only need one username and one password to access anything on the network. You can use that username and password to get control onto the network and authenticate to the network. and then authenticate using your Windows credentials, exactly the same username and password, to get access to your printers and your files and everything else. Makes it very streamlined for the end user, very seamless for the end user, and using technologies behind the scenes that we've built over time that take advantage of all these different authentication methods. A lot of different operating systems use this. A lot of different devices use this. You'll see 802.1x pop up in a lot of different places. There's a lot in this module dealing with user authentication and how it works on the network. So let's see what we remember. Our first question: what is a common authentication framework? Something that we've built so we can use it in many different scenarios, and that's EAP, the Extensible Authentication Protocol. Another question: what is a formalized set of public key policies and procedures? Something that we might have already in place so we can handle all the changes that might go on in our environment, and that is a public key infrastructure, or PKI. And lastly, what authentication method can be used to provide access control to a network? And a very common way to do that, something we see all the time these days, is IEEE's 802.1x standard to be able to authenticate to the network. Well, that's a lot in our section 6.4 user authentication module, where we've gone through our hashing and our chapping and our PKIing and our Kerberos, and all of those different methodologies certainly are all used in many environments to be able to allow us access to the network and the resources running over those networks. For many more Network Plus videos, to participate in our message boards, or to send me a message, you can visit our website, freenetworkplus.com.